Hi all. Okay, so this is the third example that I'm going over for your quiz 3 review. This is section 3.2, area of a sector of a circle. So a sector of a circle is the portion of the interior of a circle intercepted by a central angle. So for example, let's go ahead and draw a circle over here. Getting better. All right, so say you have, let's go ahead and color code it again. Let's make R in green. That'll be your radius. And then your theta value will be your central angle. Okay, it must, again, be in radians. When you are actually finding your area, okay? Again, we kind of discussed in the last problem when it's important to use degrees and when it's important to use radians when you are, basically, if I were to set my areas equal, okay, and I had different radii and I was looking for a theta value, then I would be able to leave in degrees if the problem were given in degrees. But essentially, do not think that way, except for when you actually encounter that problem. Use units to help you out. So recap the last video, look at the end of it, and then if you have any questions about what I just said about that, let me know. I know that that might have been a little confusing because I wasn't sure exactly how I wanted to say it. Anyway, okay, so here we go. You have your radius, R. Doesn't necessarily need to start from standard position. You have your central angle here, theta. And then your area is going to be this shaded bit. Okay. So that would be the area of the sector that you have. Okay. So for this particular problem, let me go ahead and save this first. And then I'm going to go ahead and clear this. Okay, I'm going to move this part down. And then we're going to go over classroom example 5. Okay. I will go into a little bit more explanation about the radian degree thing at the end. I just want to make sure that you guys do understand when we're using radians and degrees and why. All right, so find the area of a sector of a circle having radius 15.20 feet and central angle 108.0 degrees. So here we have R. Okay, let me get rid of that. All right, so R is right here in feet. And then you have your central angle theta right here. Okay. And we are looking for area. And we don't know. We have a formula for it though. Okay. So for this, you are going to need theta in radians. So your area is equal to 1/2. We have a R here, feet squared. Emphasis on the square part. And then theta It's going to be 108.0 degrees. Okay, let me quickly divert. Essentially, if you're checking, do I need radians or do I need degrees for this problem? Area, you're going to want it to come out to feet squared. Okay, so you do not want degrees to show up. If in your calculations, degrees do not cancel, you know that you're not on the right track. Okay, plain and simple way to say it. All right, and then over here, here's our conversion factor. We want to cancel out degrees with radians. So we can put pi on top and 180 below. So then your area, go ahead and plug it in. I'll kind of do this step by step for you guys. Let's just put the 1/2 down first. And then let's leave the radius part squared. I'm going to put a giant bracket around this part here for a moment, just so you know that I'm going to use associative property. Of multiplication to multiply these guys out before I do any squaring or anything over here. I'm essentially adding parentheses into my problem legally. Yay. So the reason I'm doing that is so that we can actually find what theta would be, your central angle in terms of radians first. So we have 108 divided by 180. That would give us 0.6 pi, which is the same thing as 6/10 pi. There. Come on. So many buttons. Okay, there we go. Pi radians. I miss being able to use colors. I kind of want to get a projector, a dot cam, maybe soon. All right, so just want you to know that your central angle, if you had have done it separately, theta should have been 3 pi over 5 radians. Okay. Now, continuing through, let's follow the rest of order of operations now. We have 1/2, and then we're going to go ahead and square the 15.20. That gives us 231.04. And then we still have the it's 3 pi over 5, but I'm just going to use the 0.6. Okay. Note that the units in here for your radius squared should be feet squared. You can leave that part out if it's more comfortable for you at this moment. All right, and then the rest is just a straight shot. We're going to multiply out the 1/2, the 231.04, and the 0.6 pi. Come on, no, of course I get a call now. Okay, so The area comes out to 217.75007, which is about 217.8 feet squared. Okay. All right, so that wraps up the problems that you need from 3.2. And that actually wraps up a good portion of the 3.2 problems from your notes in terms of having a video for it. All right, the next video I will have up is going to come from 3.3. It will be one problem. On to the next video.